All right, we'll move on to the next example, which will be example 19. Question 19, I should say, sorry. So question 19. And for question 19, we've got this function, y. I've done things back to front. Let's go question 18 first. Right, for question 18, we've got y equals the square root of x plus 2. Okay, so this is a function that's a little bit unfamiliar. Let's break it down into some bits that we actually do know. All right, this is the y-axis and there's the x-axis. What I do know is that, as far as we're concerned, unless you're an Extension 2 unit mathematics, Extension 2 mathematics student, you don't know anything about complex numbers, so we know that x inside a square root sign, the value cannot be less than 0. It's got to be 0 or greater than 0. So that means for this, x has got to be greater than or equal to 2. Have I written that correctly? I haven't. This is meant to be a plus sign, so x has to be greater than or equal to minus 2. It's got to be greater than or equal to minus 2. But still, what does this y equals a square root thing look like? What does that look like? Well, let's try and get rid of the square root sign and figure out what it might look like. So, to get rid of the square root sign, I've got to square both sides. I'd have y squared equals x plus 2. That is dead simple. That's just going to be, it's kind of like a parabola that's lying on its side. Instead of being a cup that holds water, it's like the cup is tipped over and it's lying on its side. And from our analysis of locus and the parabola and all the rest of that stuff, we know what that looks like. It's going to, if it was just this, it would be a parabola lying on its side and it would be convex, concave to the right. But we've got the minus 2, so that will shift the whole thing across to here, to minus 2, and it looks like that. Now, the reason why I only draw the top of the parabola is because in this original function, we're given the positive square root. We're just talking about the positive square root. If we had a plus and a minus there, you would draw both the upper part of the parabolic shape and the lower part of the parabolic shape. But we only have the positive square root, so we just draw the upper part of this parabola. That's what the function y equals the square root of x plus 2 looks like. Here's the point, minus 2. And we know that, well, that makes sense too, because x has to be greater than minus 2, so we know that. And the other boundary that we've got for this particular function is we've got the line at x equals 7. X equals 7. So we want all the area all the way up to there. It's like the leading edge of a foil, or of a wing, or something like that. So if we do that, if we look at that, then we're going to have the area will equal the integral of the square root of x plus 2 dx from minus 2 up to 7. Oh, will it actually be that? Y equals that, x dx. Yes. And so we'll have from minus 2 to 7, x plus 2 to the power of a half with respect to x. We do the integration, which gives us x plus 2 to the power of a half, and it's from minus 2 to 7, which, if we substitute these values in, I'm a doofus. I've forgotten to apply that algorithm for what we do with the powers. So that half should be 3 on 2 here, which then gives us 2 on 3. Again, the reason why this is 2 on 3 is something that we've discussed in class. You can go through the whole rigmarole of finding out why it's 2 on 3. It's a little investigation if you're not sure why. It's not a hard investigation, but you can start off with this little expression of x plus 2 to the power of 3 on 2 all over 3 on 2, and then write it like this, x plus 2 to the power of 3 on 2, I'm doing all the hard work for you now, divided by 3 on 2, which is equal to x plus 2 to the power of 3 on 2 times 2 on 3, and voila. That's what we get. That's what we end up getting. That's the sort of thing that you should be able to do by yourselves quite straightforwardly. We put in these x values into this expression now. And now that 2/3, it's going to be convenient for me to pull 2/3 out the front and just say that that's a constant multiplier, and then deal with all the x values and all the boundaries of the integration inside that bracket. So that's what I'm going to do. 2/3 is taken out the front as a constant multiplier, and we'll have 7 plus 2 is 9 to the power of 3 on 2, minus 2 plus 2 is 0. 0 to the power of 3 on 2. This shouldn't be too hard. It'll be 2/3 outside of, right, 9 to the power of 3 on 2. So think of it as 9 to the power of a half, which is 3, and then cube it, which will be 27. So this will give us 27 minus 0. And that will, in the end, 2/3 times 27 gives us 18 units squared. Oops! And over here also, units squared. Okay. Draw the sketch. Go through the process of the integration. Be careful to try and eliminate those avoidable errors. And then just do the arithmetic. It's really quite that straightforward.